Alright, so we're going to do a real quick video on equations of tangent lines. So, we previously discussed using point-slope form to represent equations of tangent lines. So what we're going to write down is a reminder of what point-slope form looks like. So we have y minus y1 equals m times x minus x1. One thing you want to remember is that m is just your derivative. So slope and derivative are really the same exact thing. Okay? So it's just your derivative. Alright? So what we're going to do when you want to write the equation of the tangent line at the given x value, we're going to need to make sure that we know y1, x1, and m, which is our slope or our derivative. We need to make sure to know the derivative at that point, okay, or at that x value. So we're going to start off by doing the derivative. So we have f prime of x equals, and we're just going to do the power rule, so negative 4x plus 2. And then we're going to go through and we are going to plug in 1. So f prime of 1 plus negative 4 times 1 plus 2, which gets us negative 2. That's our slope. Okay? So we have f prime of 1. That's our slope. Now to find y, when we already have x, we always go through and we just plug it into our original function. So that means f of 1. So you're going to do negative 2 times 1 squared, squared, plus 2 times 1, plus 3. That gives us negative 2 plus 2 plus 3, which is really, cross those out, just 3. Okay, so our y value is 3, our x value is 1, which is given to us, and at 1, our derivative is negative 2. So our final answer will be y minus 3 equals negative 2 x minus 1. Alright, so all you have to do is keep track of which one is which. So f prime is always your slope, that's m, and then we have, this is y, so y1, and then we have x is given to us, which is x1. Okay? Oh, and I'll underline this light blue also so they match. Okay? Now we're going to do the same exact thing for every other problem here. They just get a little bit scarier looking, although remember, things are just numbers sometimes. So if it gets scary, just breathe and everything will be fine. So we're going to start by doing the derivative here. So remember, coefficients don't do anything. We just want to make sure to take the derivative of sine. So the derivative of sine is cosine. So my derivative of the whole function is 5 cosine x. Then I'm going to do g prime of 5 pi over 4. So I'm going to plug it in. 5 cosine 5 pi over 4. And I'm hoping that you remember that it is g prime of 5 pi over 4. So the cosine of 5 pi over 4 is negative root 2 over 2. And we have 5 in front of it, so it should be negative 5 root 2 over 2. That is our derivative. Now, is it a nice looking number? Well, no, it's not, but we can still deal with that. And then we need to find our y value. So g of 5 pi over 4 means take 5 sine x and plug it in 5 sine 5 pi over 4. So the sine of 5 pi over 4 is root 2 over 2, positive. So that would be 5 root 2 over 2. And that's our y value. So now we can write our function. Oh, I already used purple there. So it's going to go y minus 5 root 2 over 2 equals, now our slope was negative 5 root 2 over 2 times x minus, my x value is 5 pi over 4. Now that's not the prettiest equation I've ever seen, but it's definitely not the worst. Okay? Now we're going to do the same thing for 3. So we're going to do h prime of x. Now remember, well, I'll rewrite it first actually. So no derivative as my first step, I'm just going to rewrite. So h of x equals 5 Oh, I'm rewriting. So x to the 1/2. So my derivative is 5/2. Oh, power rule. So 5/2 x to the negative 1/2. Okay, so what we're going to do is we're going to do h prime of 9. And I'm going to move this x to the 1/2 down and call it a square root again because it makes it a little easier to evaluate. So 5 over 2 square root 9, which is just 5 over 6. Okay, now for our y value, we're just going to plug it in. So h of 9 equals 5 square root 9, which is just 15. Okay, so final answer, y minus 15 equals 5, 6, x minus 9. Perfect. Now for number 4, I'm going to have you do the same exact thing. So you guys are going to get scared of this one again. You're going to get scared of it, but you don't need to be because remember, the ln properties we already know. So I'm going to rewrite this one first. G of x equals ln of 5 plus 2 ln x. Now we're going to take the derivative. What do you know about ln 5? Oh, it's just a constant? Yes, just a number. Derivative is 0, it's gone. And then 2 times ln x is going to be 2 over x. So g prime of 4, really just 2 over 4, which is 1/2. Alright, now we're going to go through and do g of 4, because g of 4 will give us our y value. So ln of 5 times 4 squared, which is the ln of 80. And then for some reason you guys want to know what that is, but I don't know what that is and I'm not going to find out. I'm just going to write it just like this. This is my y value. So I'm going to write y minus ln 80 equals, my slope is right here, so 1/2 x minus 4. It is absolutely okay that you don't know ln 80. It's just a number. It's just a number. Okay? If you want to find which x values have horizontal tangent lines, you need to think about what the slope, so we're going to fill it in with slope, what the slope of a horizontal line is. Now, because the derivative is the slope, you need to. So, the slope of a horizontal line is 0. So, what you have to do is you have to go through and you're going to set your derivative equal to 0. So, set, derivative equal to 0. Okay? Horizontal tangent line means set derivative equal to 0. So we're going to find the derivative, f prime of x is negative 3x squared plus 6x. And it says find all x values. That means we're going to go through and we're going to set it equal to 0 and solve for x. 0 equals negative 3x squared plus 6x. Okay, absolutely nothing fancy here. We're going to factor. So take out a greatest common factor. 0 equals negative 3x, x minus 2, and then we're just going to solve them. We're back in algebra 2. X equals 0, so x equals 0. And then we have x minus 2 equals 0, so x equals 2. And that's all. Now we're going to do the same exact thing for the other 3. So I'm just going to take us through it real quick. So we're going to take the derivative. Power rule says negative 4x cubed plus 16x. Then I'm going to set it equal to 0. Alright, then I'm going to take out the greatest common factor, negative 4x, left with x squared minus 4. Hopefully you remember your difference of perfect squares, otherwise your algebra teacher will be very upset. So, that's negative 4x times x plus 2 times x minus 2. Then you're going to set all of those equal to 0. So negative 4x equals 0, x plus 2 equals 0, x minus 2 equals 0. And you're going to solve them. So 0, x equals 0, x equals negative 2, and x equals 2. Okay? So I'm going to go ahead and pause and do the last two, and then you can just check with me as soon as I unpause. Alrighty, and here we go. So the only thing that you have to make sure of is that in your number 3 that you go through and actually use grouping or a box, or however you like to factor. Just make sure that your factors end up as 3x plus 1 and x minus 2. And then you solve them. So these are all exactly identical, just different factoring problems, really, if we get right down to it. So horizontal line means set derivative equal to 0. If it asks you about just writing the equation of the tangent line, then what you're going to do is you're going to go through and you're going to do the derivative, plug in the x value, plug in the x value to the original, and then go through and write your format. You need x1, y1, and the slope, which is the derivative. Okay, perfect. Thanks for listening.